been carrying on with the series SlantPro Set Up and Run, machining up some steel parts. This will be part 2, getting into setting up the tooling and the offsets and doing the conversational programming. So I'll run the part now, the end result, just quickly, sped up or with bits clipped out, so you can see where we're heading with this SlantPro machining job. So first off, I set all my X or diameter settings. That's tip of the tool for the turret, and if you've got drills, the center line of the drills. Set all the X's, don't worry about the Z's. Then put your work in, take a skim cut and set the first Z. In this case, I'm using tool number 2. Next, I'll typically set up the conversational first program and do the facing cut and machine the part to its finished length, and then I can set all the tool Z's off that finished length at Z0. So just looking quickly at that, here's your conversational. You're on your facing page. We're setting it pretty conservatively. You can't set optimum feeds and speeds on a light machine like this. You have to think about what the machine has got the power and the torque to handle, and how you're going to get your chip braking to work efficiently, or at least chip curling, so that it'll run automatically and you can leave the machine unattended. Post that to file and run that program. Let's just do that now. Okay. So I've just run the part, but I'll just run it again to get the idea. Obviously you have your maximum velocity sliders down very slow the first time, so that you're checking for tool clearances and that you haven't made a mistake. So we're doing 2 fairly rough facing passes here, 1mm depth of cut each time. This is the final roughing facing pass, and then finally the finish one. I won't bore you with that. Quite a slow pass, just to give a nice finish on the end. There's the bush there, a pretty basic part. So now I'm going to conversationally program the OD, outside diameter turning, and this is lovely, this software, isn't it? So quick and easy to use. So we're just calling it OD, or the thickness of the chip, if you like, a 0.25 or 10 thou, and a finishing of 0.1 or 4 thou. The depth of cut here is 1mm. That's 2mm on the diameter. I know the lathe can handle that, so I'm not going to push it. I don't want to be 99% at stalling point. I want to be able to go away and do something else. And when we've entered in the values, we can post it to a file, so it's just a one-off file to run that file separately, and if that's okay, then we can append it to the first file, so that we're building up a group of files or codes. I don't like the way the conversational does the finish pass. The final diameter is 35 by 20 deep, and there's the last roughing pass there, 35.4 by 19.8 deep. That's fine, but look at the finish pass. It goes to 35 by 20 deep. So that's the full width of the tool plunging into 20mm. That would probably stall the spindle, and I don't know why they insist on leaving that in the software. You shouldn't do that. You should never cut full width of the tool. That works fine if you've got a very steep rake tool, like a profiling tool, but it's not suitable for a roughing tool, and so I need to edit that. So here I've changed the finish pass Z depth to back to 19.8, not minus 20. Then it comes out to the outside diameter, sets it in at 20 millimeters, and then does a facing pass down to the 35. That is a much more conventional and safe way to cut that final finishing pass with that shape of tool, with a roughing tool. While I'm on the subject of chip breaking and depth of cut and feed rate, so you want the chips to come out like that, obviously, with a decent curl on them and not too long. You don't want them coming out like that. So the roughing millimeters per revolution is critical. This curly chip was 0.2 millimeters a revolution. That's 1/8 thou, and this curly chip here was 0.25. That's 1/10 thou. So you need a fairly coarse feed, a fairly deep cut per revolution in order to get chip breaking. But if I went any higher, I might stall the spindle, so there's a narrow window there where you need to set it just right. You need it to run automatically with good chip breaking so you can do something else. You don't want to have this sort of swarf. It not only that, but it fills up a huge amount of volume. You need massive big bins. I mean, in no time your swarf bin will be full of springs, wiry springs, if you don't set that right. So there we are, that's the OD turned in chamfered. Most of you will be familiar with the conversational, so I won't go into it in too much long-winded detail, but you open it up in conversational file edit or file converge, and then those one-off codes that you've produced, you just keep inserting them. So if I insert a file here, I'm going to put in the second OD chamfer, and there it is there. So we've got face, OD, and OD chamfer 2. They're a little bit out of order because I'm talking and clicking at the same time, but you can adjust the order by moving them up and down, and I'll just do that now. So you can see here I've got the chamfers coming in before the turn. That would be a nasty crunch up, wouldn't it? So have a look at it here. I can just move up. So now I've got face, OD, OD chamfer 2 and OD chamfer. So it'd be nice if that one was before the other one, so I'll move it up. So you can adjust the order like that. Face, OD, OD chamfer and OD chamfer 2. And then you can save as, find a file name for it, and so on. I'm having a bad hair day today, you know, on those days when you've only got half a brain, but it's probably good to do a video like this sometimes because you can still do CNC machining with half a brain. It's just a bit scary. So the correct button for that editing is conv edit. I suppose that means conversational edit, and it's saved. We've got it saved here to this file, and you can see all of those different little short bits of code are all put together now under Bush. Once you've got an end machine, you can set all of your Z tool offsets to that end. Here's a trick for setting your X or your diameter for a boring bar. See, there's your boring bar there. You can put a straight edge like a parallel over there and then just tip it round, if I can show that, until you get it to the closest point to the tip, and then just index out on the X until it's just touching. You know that diameter, a measured diameter, is 35 millimeters, and you can set it there through this tool offset setting DRO. So you can set your drill X position this way with your half round piece of aluminium, that's the center line, touch it up on the flute of the drill of a known diameter and enter that diameter. So we have a 17 millimeter drill there. So we've set our X there at 17. These parts are being made out of commercial quality mild steel, you know, that grade that's suitable for welding, a very low carbon mild steel, and it's not very nice to machine. It's teary and sticky, and so I thought I'd try out this high clearance boring bar tip. I've never really liked these because they're so fragile and weak, but it's working really well. It gives you more clearance in the bore, and when you're CNC boring, it's quite a difficult situation. When you're doing it in a manual lathe, you can manually back out the tool and flick out the chips with a wire hook or a brush, but you want the CNC to run automatically, so you've got to have your settings optimal. It's got to run smoothly and cleanly and not be jamming up with chips, so that high clearance on the shank diameter is a good feature to have, and it's the first part and it's gone really well. Perhaps this will explain it better. What I mean by these high clearance profiling cutters is that you get a lot more clearance between the shank of the tool and the bore, and that's really important for automatic running, unattended running. You know, because a conventional boring bar is much stronger and can take bigger cuts, but you can easily get the swath, the chips jammed up in the bore, and on a manual lathe you have to back off and clear it out and flick out the swath and so on. But you don't want that in a CNC lathe. You want it to run unattended, and so I think it's worth having a weaker tool that takes smaller cuts, but you've got more clearance. No, that works really well. I'm glad I tried it, because production boring, the ID in non-free machining steel, is quite difficult to get it to run automatically so you can let it go. So the settings for that is a 0.8 depth of cut, a 0.15 feed, that's about 6 thou, and 100 meters per minute. Here's a view of that high clearance or profiling geometry boring bar that's inserted in a 10mm holder. There's the tips there, DCMT, and I've just been getting these cheap Chinese copies. I sort of feel a bit guilty doing it, but I wanted to try the idea out without spending big money on Sandvik or Iskar, and they seem to be holding up quite well. So it's certainly a low cost option to get you started anyway. Thanks for following me on this, guys. Catch you later.